All right, folks. So today is a big day. In this particular lesson, we are now going to pull together everything that we have learned, or most of what we have learned over the last several lessons since the beginning of Unit 2. And we may even take in some of the stuff that we learned in Unit 1 to understand what we call in trigonometry, we call it the unit circle, okay? And it's especially useful as you learn higher levels of math. If you move on to calculus and higher levels of calculus and move into other areas of engineering and that sort of thing, you are going to need to have in your mind the basics of the unit circle. So let me explain very simply in math what the unit circle is. And I'm going to use a graph to help you, or to help us. All right, so here we have a coordinate plane. Okay, we've got a y-axis, we have an x-axis, right? And we can count along the x-axis and the y-axis, right? We have 1, 2, 3, 4, 5. -1, -2, -3. We can count up along the y-axis, 1, 2, 3, 4, 5, 6, right? Negative, -1, -2, -3, -4, whatever. Okay, this is just a regular coordinate plane. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay. So a unit circle, or the unit circle, what is referred to as the unit circle, is actually just a circle that on the coordinate plane that has its center at 0, 0. Okay, so the unit circle has its center at 0, 0, and it has a radius of 1. So it's a circle with a radius of 1. So if we go from here over here to 1, that is the radius of this circle. And we can go over here to a radius of 1, and down here a radius of 1, and up here a radius of 1. So we know that in all directions, this circle, it's very, very terrible drawing of a circle. But very simply, what you're looking at right there, that is the unit circle. But in order for me to sort of explain to you, or for us to use the unit circle as a tool, this looks way too tiny, okay? I'd like to use a little more of the whiteboard. So what I'm going to do is I'm going to zoom in on the unit circle from here. And now if I zoom in, we can actually make it to where we can get it large enough. There we go. We can get it large enough to where we can use we can see it up close. But this is still the coordinate plane. It may look like, we've zoomed in really far, but, here's the y-axis, here's the x-axis, and if we go, here's 0, 0, this is 0, 0, okay? Right? This point over here is, that's 1, 0. This point down here, that's, 1 and, 1 and -1, all right? And up over here, this point, this is -2 and 1. I'm just trying to help you have understand that all we did was zoom in, and we're just looking really close at the coordinate plane. But the area we're going to be concerned with is just in here. We're going to draw a circle that has a radius of 1. Okay, so it goes up to here, and it goes over to here. Let's go here, and down to here, and over to here. Let me get rid of this. So it has a radius of 1, and it is on the y-axis. It's right at the center of where the y-axis and the x-axis connect, and it creates a circle. Again, I've made a very ugly circle, but very roughly, that is what we call the unit circle, okay? So what I'm going to do now is I'm going to draw a prettier one that's more precise, that we can use to understand this tool, the unit circle in trigonometry. Okay, so I've gone ahead and created a little more accurate circle. Now here's what I want to remind you. We're looking at the y-axis here. We're looking at the x-axis. That makes this point right in the middle. That makes the center of the circle the point 0, 0. Okay? 0, 0. And since the radius of this circle is 1, that means from here over to here is 1. That makes this point over here the point 1, 0. And if we can go 1 this direction, this is the x-axis, so this is the negative direction. So over here, this is the point -1, 0. If we start at 0, 0 and go up 1 unit along the y-axis, that makes this point 0 and 1. And then if we go from the center, from the origin, down 1 unit, that makes this point right here 0 and -1. I just want to remind you that this is a coordinate plane, and I didn't draw in the grid lines here and here and here and here because we do not need those grid lines. But here's what I need you to keep in mind. It's important for you to understand that every single one of these points, every point along the circle is a coordinate, has an x and a y coordinate. Now I do want to point out that I have highlighted the 16 points that we were working with in Lesson 12. One of the reasons that I had you do that in Lesson 12 was so that you could understand the basic proportions of the distances relative to the origin of these points. And hopefully you remember what those proportions are. We're going to get to those in just a little bit. Remember when we learned about arc length, right? We learned about how, the arc length is measured in radians, and then we translated the arc length into an angle measure, right? So for example, at this point right here, if we were to start here, and if we were to go up to this point right here, the length of that arc, because it's 1, so if we break it up into the whole pie into 12 pieces, skip this one, okay? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? That's 12 pieces. This is 1 of 12, right? And so that's 1/12. And we know that the circumference of the entire circle is 2 pi. Remember, the radius of this circle is 1. So 2 pi r, 2 pi times radius of 1 equals 2 pi. So the circumference of the entire circle is 2 pi. Well, 1/12 of 2 pi is equal to 2 pi over 12. And if we were to simplify that, it becomes pi over 6. So we know that the distance from here to here is pi over 6, right? Well, here's what we're going to do, is we're going to, and you already know this, we are going to, by the way, the radius of this circle is about 1 foot. We are going to use that idea. I'm going to use a different color here. And we did this in Lesson 9, is we're going to take the radius, or the arc length, and we're going to use that to represent the angle created by the positive side of the x-axis with what we call the terminal side. So here's the initial side of the angle, and then here's the terminal side of the angle. And because the terminal side of the angle ends or hits the unit circle at pi over 6 radians, we call that angle a pi over 6 radian angle. Okay? So by doing that, and by doing that all the way around the circle, we can identify several angle measures around the circle. And for each angle measure, we can identify the trigonometric ratio. So for pi over 6, we can identify the sine of an angle pi over 6. We can also identify the cosine of pi over 6. We can identify the sine and cosine of every single one of these 16 points around the entire unit circle. And then if you understand that, if you memorize that, which seems sort of difficult right now, but trust me when I say lots of people have memorized this unit circle, and you will as well, or hopefully you will as well. Once you know that, you can then use those proportions to also understand the tangent, the cotangent, the cosecant, and the secant. Because remember what I said in the last lesson, as long as you know just one of the trigonometric proportions, you can then use that to find all of the other trigonometric proportions. Okay? Now, you may say, why do I have to do this? Well, honestly, in order for this to really, really matter, you have to be going into an area that cares a lot about dealing with triangles, which is usually engineering or surveying or something like that, okay? All right, so there are two things that we're going to learn. I'm going to erase these coordinates for now. There's two things. Every single one of these points, these 16 points, are very important. And every one of these 16 points is going to have two things about it. It's going to have a radian angle measure, which can also be converted into degrees. So every point has an angle measure associated with it, whether radians or degrees. We're going to deal in radians in this class. So every single one of these points has an angle measure associated with it, and every single one of these points has coordinates, an XY coordinate. So on the inside, we're going to put the angle measure, theta, and on the outside, we're going to put the x, y coordinates for every single point all the way around the unit circle, okay? So what we're going to start with right now is we're going to start with identifying the angle measures for each one of these. And so to do that, we're going to have to reach back in our minds to lesson 9. All right, so let's start by identifying this one, kind of the ones that are on the middle. We're going to identify this one, this one, this one, and this one, okay? We're also going to identify this one, this one, this one, and this one. So we're going to identify 8 of them, okay? The first half. Now, these are the points when you think in lesson 12 where you had to identify the coordinates of a circle somewhere on the coordinate plane. I've referred to these as the 45-degree angle or the middle points, right? And the reason that I refer to them as the middle points or the 45-degree angle points is because they are literally halfway from here over to here. This one is halfway from here over to here. This one is halfway from here over to here, etc. And since this is 90 degrees, since perpendicular makes 90 degrees, halfway of 90 degrees makes a 45-degree angle. So we know that this is a 45-degree angle. But what is it in radians? Well, we could convert 45 into radians and we would get pi over 4. But here's another way that we can understand pi over 4 is you can see that by splitting it up like this, we have 1 pi slice, 2, 3, 4, 5, 6, 7, 8 pi slices, right? We know that the circumference of the unit circle is 2 pi, because 2 pi r, the radius is 1, so 2 pi times 1 is 2 pi. So the circumference all the way around is 2 pi. We're going to do 1. To get this one, this angle measure, we're going to do 1 out of 1, 2, 3, 4, 5, 6, 7, 8. So this is 1/8 of 2 pi. That gives us 2 pi over 8. 2 over 8 can be reduced to 1/4, so this is pi over 4. And so that means that this angle right here, the angle created by this terminal side with the initial side here, this is a pi over 4 angle. So what we're going to do is we are going to write right here, we're going to write on the inside, we're going to write pi over 4. That point will always represent a triangle whose angle measure is pi over 4. So for example, you've seen this already, the right triangle. So if I put this right in here, you can see that because it goes to right here, that makes this angle right here pi over 4. And since this is a 45, 45, 90 right triangle, this angle up here is also pi over 4. And so we can use that to understand the sine of the angle and the cosine of the angle and the tangent of the angle. Okay? All right. So let's go a little faster through the rest of these. So this is pi over 4. So now let's do this one up here. We're going 1, so we're going 1, 2 out of 8, right? So 2/8 times 2 pi, that's going to give us 4 pi over 8. 4 over 8 cancels to 1/2, that makes pi over 2. So we know that this point up here has the angle pi over 2, which is a 90-degree angle, okay? So this is pi over 2. Pi over 2. Okay? Coming over here, we've got 1, 2, 3 out of 8. Okay, so that's going to be 3/8 times 2 pi. That's going to give us 6 pi over 8. 6 over 8 reduces to 3/4. So that's 3 pi over 4. Okay, so this point right here is going to represent the angle measure. Now the angle measure goes from here over to here. That's this angle measure that this is representing. So this angle measure is 3 pi over 4. Okay? Now down to, over to this one right here. So we've got 1, 2, 3, 4 out of 4. Okay? So 4 out of 8. 1, 2, 3, 4 out of 8 times 2 pi. 2 times 4 is 8. So that's 8 pi over 8. The 8's cancel and we get just pi. But we already knew that. So this point right here is pi. By the way, I forgot to put one over here. At the starting place, we have no angle at all. That makes this 0 radians. So we have 0 radians, pi over 4 radians, pi over 2 radians, 3 pi over 4 radians, and then pi radians. So now let's move down here to this one. We've got 1, 2, 3, 4, 5 out of 8. So we have 5 out of 8 times 2 pi gives us 10 pi out of 8. Both of these are divisible by 2, so that is reducible to 5 pi over 4. So that means this angle measure, the angle measure that starts here and goes around to here, that is the angle measure 5 pi over 4. Okay? Now let's come down here. We've got 1, 2, 3, 4, 5, 6 out of 8 slices. Okay? So 6 out of 8 times 2 pi. Just 2 pi, we can put 2 pi over 1, I guess, but 2 pi becomes 12 pi over 8. 12 and 8 are both divisible by 4, which becomes 3 pi over 2. And so this point right here represents the angle measure 3 pi over 2. Okay? And now, coming up to this angle right here, we've got 1, 2, 3, 4, 5, 6, 7 out of 8. Okay? So that's 7 out of 8 times 2 pi gives us 14 pi over 8. Both are 14 and 8 are both divisible by 2, and therefore this becomes 7 pi over 4. And so this angle measure right here that goes all the way around to here, this really almost completes a circle angle measure. This is 7 pi over 4. Okay? All right. So now what we're going to do is we're now going to move on to being able to calculate this one, these two, and also these two. That's the other 8 points right now. Okay, so to be able to now identify the angle measures here, here, and all the way around, what I've done is I've used these lines to slice up the circle into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 equal parts. So now we'll be doing out of 12 times 2 pi, because remember the circumference all the way around is 2 pi. Oh, speaking of which, I forgot to mention, this is 0, right? But if we go all the way around, if we do the entire distance all the way around, a full circle angle is a 2 pi angle, because that's the circumference. Therefore, the angle associated with all the way around is also the circumference, which is 2 pi. Okay? So this point right here represents both 0 and 2 pi. They are coterminal angles, right? 0 plus 2 pi is 2 pi, and 2 pi minus 2 pi is 0. Therefore, 0 and 2 pi occupy the exact same place on the unit circle. Okay? They represent the same angle. Well, basically the same angle. Okay? So now what we're going to do is let's identify this point right here. Well, that's one slice. That's 1 out of 12. We already did this, I know, but we're going to do it again. 1/12 times 2 pi is 2 pi over 12. Both of these are divided by 2, or divisible by 2, so the top becomes pi, and the bottom becomes 12 divided by 2 is 6, so it's pi over 6. So this point right here is represented by the angle measure pi over 6. Okay? All right, now let's do this one right here. If we're right here, we're 2 slices out of 12. Okay, so 2 slices out of 12 times 2 pi is equal to 4 pi over 12. We can divide 4 by 4. We can also divide 12 by 4. 4 divided by 4 is 1 pi, but we don't put the 1, we just put pi, right? So it's pi over 12 divided by 4 is 3. So this point right here represents an angle measure. That angle right there for this angle is pi over 3, which, by the way, is also a 60-degree angle. If you were to take a 30, 60, 90 right triangle and put the 30, 60, 90 right triangle in there, look at that. You would get this angle right here is a pi over 3 angle. That's 60 degrees. If you were to put in a 30, 60, 90 right triangle right here where the pi over 6 is, look at that. You'd get a pi over 6 angle or a 30-degree angle. So this is a pi over 6 angle, this is a pi over 3 angle, and then a 90-degree angle is a pi over 2 angle. Okay? All right. All right, so we've got pi over 6, we've got pi over 4, pi over 3, pi over 2. All right, now this one right here is going to be 1, 2, 3, 4 slices. So that's 4 out of 12, okay, times 2 pi. 4 times 2 pi is 8 pi over 12. Both are divisible by 4, and so 8 divided by 4 becomes 2 pi. 12 divided by 4 becomes 3, so it's 2 pi over 3. So this point right here is 2 pi over 3. Now you should be producing this with me. Right now you should have a, I don't know, get a can or something that'll allow you to draw a circle, a good circle on a piece of paper. Draw a vertical line straight through the center, draw a horizontal line straight through the center, and then just start putting these dots. They don't have to be perfect. I tried to make them as perfect as possible because I'm teaching it. But you just need to understand generally that there are 3 in the middle over here, okay? So you should be doing this also. So that's 2 pi over 3. Now let's identify this point over here. We got 1, 2, 3, 4, 5 slices out of 12. So we've got 5 out of 12 slices times 2 pi becomes 10 pi over 12. 10 and 12 are both divisible by 2, becomes 5 pi over 6. So this is 5 pi over 6. 5 pi over 6. Okay? Then we have pi, okay, which, by the way, is proved by 1, 2, 3, 4, 5, 6. 6 over 12 is 1/2. 1/2 of 2 pi is pi. Okay? All right, let's come to this one down here. Now we got 1, 2, 3, 4, 5, 6, 7 slices. So 7 slices out of 12 times 2 pi. Okay? 7 times 2 pi is 14 pi over 12. Both are divisible. 14, 12 divisible by 2. So we get 7 pi over 12 divided by 2 is 6. And so we have 7 pi over 6. So this point is 7 pi over 6. Okay? And this one down here, we've got 1, 2, 3, 4, 5, 6, 7, 8 slices out of 12. So 8 out of 12 times 2 pi becomes 16 pi over 12. 16 and 12 are both divisible by 4. 16 divided by 4 is 4, then a pi. 12 divided by 4 is 3, so 4 pi over 3 goes right here. 4 pi over 3, okay? Then 3 pi over 2 is proved by 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 over 12, 9 times 2 is 18. 18 over 12 is 3 over 2. All right, so now let's do this one here. We're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 slices. Okay, so we've got 10 slices out of 12 times 2 pi. That gives us 20 pi over 12. Okay, 20 and 12 are both divisible by 4. 20 divided by 4 is 5, so 5 pi. 12 divided by 4 is 3, so 5 pi over 3. So that's going to go right here. 5 pi over 3. And then the last one right here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 slices. So we've got 11 slices out of 12 times 2 pi becomes 22 pi over 12, both divisible by 2, giving us 11 pi over 6. So this angle measure right here, which, by the way, starts here and comes all the way around to here, that angle measure is 11 pi over 6, okay? And so now what we have, if I get rid of all these get rid of the little green lines, what we now have, what you were looking at is a complete unit circle with all of its angle measures, okay? And what I'd like to do right now is I'd like to break out just for a second and give you a couple minutes, maybe about, it might take you about 4 or 5 minutes. I want to show you a blank unit circle. I want you to get a blank sheet of paper, and I want to see if you can, without looking at your notes, draw in all of these angle measures at the correct points, okay? So I'm going to be back in a second and we'll do that. Okay, so we have a blank unit circle. I want you to have a blank unit circle on a piece of paper in front of you without your notes. And then I want you to pause this video and I want you to try and fill in the radian angle measures for all 16 points. Go. Okay, now I'm going to do it. I'm going to talk you through it as I go. I know that this one is always 0, and I also know that it's 2 pi. So I'm going to put in 0 and 2 pi. Okay. I also know that this one over here is pi, so I'm going to put pi over here. Okay. I also know that halfway between here and here is here. This is halfway, so that means half of pi, or pi over 2. Okay. Now, I also know that this point and this point are the only ones that are over 2. So this one's over 2, this one's also over 2. So down here, I'm going to put over 2, okay? So that's a 2, it's an ugly 2, and look at this. Here's 1 half, 2 halves, 3 halves, that makes this 3 pi over 2, or 1.5 pi. If this is 1 pi, this is 1.5 pi, and this is 2 pi over here. So that's how I got the 3 pi over 2. Another way is, and I'll show you in just a few minutes, that basically over here, kind of over in this area here, you can basically add 1 to the denominator. So this is a 2, so you can add 1 to it, and you get a 3, and that makes it 3 pi over 2. And I'll show you that over here. Now I know up in this quadrant, none of them has a number in front of the pi. All of them are pi over something, pi over something, pi over something, okay? And I also know that halfway is 4, right? Basically, here's what I know. I know that this is 2, this is 3, and this is 4. So I got 2, 3, 4, so over 3, over 4. This isn't 5, though. It's half of the distance to pi over 3, so that makes it pi over 6. Okay? And so I got pi over 6, pi over 4, pi over 3, pi over 2. And what you're going to find is, as long as you can memorize this quadrant, it helps you with the other quadrant. Because here's the cool thing. From this pi over 3, I can go straight across to this one. If I go parallel or straight across, this is also an over 3. If I go straight across on this one is also an over 4. And if I go straight across from here, this one is also an over 6. In fact, what you're going to find is that all of the middle ones are all over 4. All of the middle ones are over 4. And the ones that are closer to the x-axis are all over 6. So this one is also an over 6. And this one right here is also an over 6. Okay? And the ones that are closest to the y-axis are both over 3. See, I go from here straight across to an over 3, but if I can go straight down to here, that's also an over 3. And then if I go across from here, this one is also an over 3. So these basically create rectangles or squares from the over 4s, rectangles from the over 6s, and rectangles from the over 3s. Okay? And so now, to try and remember what goes on top, there's a couple ways of doing that, okay? I know that this is 2 pi over 3, and there's a couple reasons I know it. Up in this quadrant, basically you subtract 1 from the denominator. So 3 minus 1 is 2, and that's 2 pi over 3. Another way of understanding it is, here's 1/3, and here's 2/3 around a pi. So I got 1/3, 2/3, 3/3 of pi, okay? For fourths, I have 1/4, 2/4, and that makes this one 3/4. So it's 3/4 of pi, or 3 pi over 4. I can also subtract 1 from the 4, giving me a 3, and there's my numerator. If I subtract 1 from 6, I get a 5. That makes this a 5 with a pi. 5 pi over 6. Another way of doing it is 1/6, 2/6, 3/6, 4/6, 5/6 of pi, and then 6/6 of pi makes just pi. Okay? All right, now this quadrant down here, you add 1 to the denominator. So if I add 1 to 6, I get a 7, right? So that makes this 7 pi over 6. Another way of understanding it is 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6 of pi. okay? Here, if I add 1 to 4, I get a 5. So I get a 5 pi over 4, right? Or I can say 1/4, 2/4, 3/4, 4/4, 5/4, okay? Making this 6/4, and 6/4 is the same thing as 3 over 2. Now this one, I'm going to add 1 to the 3, giving me a 4. And that's 4 pi over 3, okay? So another way of doing that is 1/3, 2/3, 3/3, 4/3, okay? And then we got 3 over 2. Here's my 5/3. Okay, so here 1/3, 2/3, 3/3, 4/3, then 5/3. 6/3 would be 2 pi. Okay, so this is 5/3 of pi. Now, here's the tricky way that you get that number from the denominator. You double the denominator and subtract 1. So 3 times 2 is 6, minus 1 is 5. 4 times 2 is 8, minus 1 is 7. That makes this 7 pi over 4. 6 times 2 is 12, minus 1 is 11, making this 11 pi over 6. And I have completed all of the radian angle measures in my unit circle. Okay? All right, now what we're going to do is we're going to go on to understanding how do we identify the coordinates on the outside of the unit circle.